but I don't see the presentation anymore. Okay, fine. Good morning, everyone. My name is Francesca Palumbo. I'm Associate Professor at the University of Cagliari in Italy, and I'm the Scientific Coordinator of the MYRTUS project. MYRTUS stands for Multi-Layer 360-Degree Dynamic Orchestration and Interoperable Design Environment for Compute Continuum Systems, and it's a consortium. It's an Horizon Europe project started in January 2024, and the consortium is composed of 14 different countries that we grab together. Fundamentally, we have different expertise, going from low-level architecture design to software management strategies. The projects aim to provide solutions for the efficient computing. I don't know whether you are seeing the presentation, to be honest.
We are on the first slide.
Oh, gosh. Okay.
Okay, now it's moving back and forth. Ambition in a nutshell.
Okay. And the goal of our project is to provide efficient solutions for computing continuum management, leveraging AI strategies. Three different ingredients are composing our project. The first one is the definition of a reference computing continuum infrastructure, which peculiarity is the fact that it's composed by heterogeneous resources to be managed through these to be orchestrated and managed by MYRTO, which is an AI-powered cognitive engine that represent the core of the project and is capable of managing both workload and customization and resource customization at runtime. To deal with the complexity of the design of such an environment, we are also defining a design and programming environment. It's a unified end-to-end environment covering all aspects that going from high-level modeling down to deployment. All of these three main ingredients and main technical goals are to be assessed or in the process to be assessed, I would say at the moment, into two use cases, which I will not cover today because I'm going to focus mainly on the technical on the key technical pillar. The two use cases are one on mobility and the other one on healthcare. So the first challenge that we are facing is a widely known one, is the cloud edge dichotomy, and we are all used to hear about pros and cons of centralized cloud-based solution and decentralized edge ones. The computing continuum paradigm, as we all know, has emerged to overcome these issues and the limitation of the individual approaches. But despite all the presentations that the nice presentations that we have seen today, I think we can agree on the fact that there are no widely accepted solution, and that all the frameworks that are around are mostly fragmented and proprietary. What we are doing in MYRTUS is to try to define this reference computing continuum infrastructure following the guidelines of the standardization initiatives that is called EUCHE. In MYRTUS, what we are doing is defining this infrastructure that is composed by an heterogeneity of computing resources that spans from edge to cloud, that include also application specific at the edge, application specific accelerator. So all the nodes that we are considering are highly heterogeneous and highly customizable. All of these nodes are brought together, exploiting virtualization techniques, among which I can mention that we are using Lico, that is from Aruba Cube. The goal is to enable the seamless orchestration, of the workloads across all these resources. Here is with this slide, I wanted to summarize the fact that we are trying, as I said, to adhere to the building blocks that have been defined by the EUCE standardization initiatives, and I want to mention the fact that for example, for resource management and orchestration, we are using in all layers Kubernetes and Lico, so from the cloud to the edge, and virtualization technologies like Docker to establish this continuum of resources. The second technical challenge that we are facing is apart from the creation of this continuity of computing resources, also the orchestration of these resources. And again, the dichotomy that we have seen at the infrastructure level is also there at the management level. For example, Lico, that is the technology that I mentioned before, provided by Aruba Cube, before MYRTUS was capable of really seamlessly bridging together different clusters of resources in different cloud regions, but never stretched till the edge, where heterogeneity makes difficult to adopt it. What is the effect of this limitation is the fact that there are severe limitation of the optimization potential that you can have at runtime if you are considering the different layers as isolated silo. What we discovered when we started MYRTUS is the fact that algorithms for workload optimization are certainly there, but they struggle in coping with the heterogeneity, and they struggle in really offering cross layer management of the resources. And here is where we are trying to advance the field. Indeed, our goal is to exploit artificial intelligence for orchestration purposes, trying to realize the self-adaptation loop that is typical of autonomic system. The orchestration and reconfiguration of the system and the workloads running on top of it, it's triggered in our case not only by latency related matters that are mostly the triggers that is mostly seen around, but also by energy efficiency, by energy efficiency and security guarantees. We do that by deploying MYRTO, that is our orchestration agents. The continuous monitoring and observation that are enabled at the infrastructure level allow MYRTU to make informed decision regarding resource allocation, task scheduling, and system reconfiguration. So these MYRTU agents that you see here not only allows to redistribute at runtime the different workloads from one node to another, even among different layers, but also to configure the different resources at the edge. MYRTU is used both at deployment time. In that case, it also leverages some information that comes from the MYRTU's design and programming environment and combine those information with those that are stored in the distributed knowledge base resource registry, but also at runtime. And the triggers at runtime may come either from the application, so come from the users, or from condition that can happen at the node level. So, for example, failure of some particular node. The goal, as I said, is to enable this continuous optimization at runtime. To favor the uptake of our solution and allow the portability of MYRTU technologies, we are leveraging standard technologies that I already heard in the other presentations. For example, to orchestrate the deployment of the workloads, our deployer uses Kubernetes and Lico, and makes use of Docker images for container definition. Moreover, we are adopting, and I think I heard it also in other presentation, we are adopting the Tosca language to provide MYRTU with a model-based description of the infrastructure and the services, and to annotate the characteristics such as the requirements or the operational policies to be taken into consideration. Last but not least, as I said at the beginning, to handle complexity, we are also defining a design and programming environment. Indeed, one of the biggest problem in a computing continuum infrastructure is the fact that there are many instruments available to program and deploy solutions either in the cloud or in the edge, but rarely these solutions converge with each other. So in the context of continuum computing, there's a clear need and there's a clear gap for a design and programming environment capable of cross-platform support capability. And this is where we are trying to invest our effort in. We are creating this design environment that go from the initial application level specification down to software components and accelerator bitstream definition. And this design environment, apart from spanning, as I said, from end-to-end, so from definition down to deployment, has also some important key ingredients that are security and privacy by design, support for deployment and runtime orchestration, and cross-platform compilation to avoid vendor lock-in. Even in the design and programming environment, to facilitate the easy uptake of our solution, we leverage industry and academia backend frameworks, again, Tosca to describe the application, but also MLIR for cross-compilation purposes. The DP is quite complex. It's composed of three different steps. In the first one, we analyze the application, we prepare the Tosca model for deployment, and we also define the attack defense tree that is useful for risk analysis, and that is used in the second step of our DPE for defining and automating the countermeasure definition. In this second step, is called model to implementation, because we take the initial Tosca model. We are capable of doing automatic code generation and countermeasure synthesis and countermeasure synthesis. Having available the models, the C++ models, then everything is digested by the third step of the framework, where we leverage MLIR, an MLIR-based environment to create both to compile both the deployable microservices and to define the specification of the hardware accelerators. The goal, as I said at the beginning, is to create a unified environment for users to be able to deploy complex application in heterogeneous cloud edge computing infrastructure. This concludes mostly my presentation. It was just an overview of the key main ingredients of the project. I leave you with some links. In particular, we have a Zenodo community where you can find all the publications and also the deliverables of the project. Thank you for your attention, and also for the invitation to this very nice event.
Thank you very much, Francesca, for the very interesting presentation. Is there any quick question before we close the info day, which has been a bit late, sorry. Tony, who moderated the first half of the info day, has been much better than myself in moderation. I got a session which started earlier, and I have a session which ends late, but it is entirely my fault. So, okay, if there's no burning question, I would thank everyone for being here. Yes, Piros?
Yeah. So thanks, Francesca. In one of the slides, I noticed that you target also FPGA-based nodes. Can you tell more about the targeting, the focus targeting of FPGAs? For example, for ML models, things.
Actually, we have. It's a great question because it's my field. Thank you. And we are working on different type of FPGA, FPGA nodes. We have a flow for it's called ONNX to MDC. There's a paper on Zenodo for that, and starting from ONNX model, we are able to infer CNN models on the processing logic of the FPGA, and everything can be orchestrated within the MYRTUS environment, because on the processing system side, we have this software stack that comprises Kubernetes lightweight version of Kubernetes and Lico to orchestrate containers that can do ML. But it's not the only type of accelerators. There are also accelerators for other type of applications. We are using Artico framework from UPM, and also a CGRA reconfigurable RISC-V implemented on FPGA, again from UPM. So there are very different types of FPGA nodes there that can be exploited. The good thing is that all of them interface with the MYRTU cognitive engine with the same software stack that allow us to connect the nodes.
Okay, thanks a lot, Francisca.
Thank you for the insightful final discussion. So I thank all the speakers of the Info Day, and I think this takes us to the conclusion. I thank you also the attendees for bearing with us until now, and I wish you a nice continuation of your working day and week.